Hello everyone. I Yuvraj Sonare, Senior DevOps Engineer from DevOps. I welcome you all to this webinar on the topic of DevSecOps challenges, overcoming hurdles in secure development environment. Then we have agenda in this webinar. We will go through challenges associated implementing DevSecOps, DevSecOps best practices and strategies to overcome the challenges. And at the end, we will have a demo of DevSecOps in DevOps pipeline. So before we go ahead and see the other slides, I would like to have a poll here. So to understand the development practices your team uses. So let me run a poll here. We have a poll question is that which development practice does your team use? And we have options one DevOps, and second DevSecOps, and third neither. I'm getting responses from you guys. Yeah, few more seconds to go. Okay, so 75% are saying DevSecOps, and only 25% are saying DevSecOps. So, based on the responses, I can say that good to see that you are practicing DevOps, and this webinar will take help you to take the first step towards DevSecOps. As per the Gartner report, 50% of organizations have implemented DevSecOps. 31% organizations are in the implementation process, while 11% plan to implement DevSecOps. Therefore, let us see the DevSecOps challenges that others have in their business strategy. Here we have listed challenges associated with implementing DevSecOps. So let's discuss these in detail in upcoming slides. One of the main challenges of DevSecOps is the lack of skills and awareness among developers, security professionals, and operations team. So developers may not have sufficient knowledge or experience in security best practices, tools, and standards. Similarly, security professionals may not be familiar with the development methodologies, tools, and environments. So, like operations staff may not be aware of the security risks and requirements of the software products they manage. Then we have cultural resistance. Developers and security teams may have different goals, mindsets, and workflows, which can lead to conflicts and silos. It can be challenging to get development, security, and operations teams to work together as they may have different priorities and ways of working. Next, we have is communication and collaboration. Effective communication and collaboration between teams is a fundamental requirement for DevSecOps success. Overcoming communication barriers and fostering collaboration can be a challenging one. Then we have security testing. Integrating security testing tools into the DevOps pipeline can slow down development if not done efficiently. Also, we need to ask a question that how often are systems and applications tested for security issues? Let's talk about the next challenge, regulatory compliance. Ensuring that DevSecOps practices meet regulatory and compliance requirements is essential, especially in industries with strict security regulations, for example, healthcare and finance. Adhering to these regulations can be a challenging one. Ne- Next, we have Threat detection and response. Detecting and responding to security incidents and threats in real time is crucial one. So building and maintaining effective threat detection and response capabilities can be a significant challenge. The next one is the infrastructure challenge. So moving resources to the cloud is a very popular and current trend in the software industry. The move to the cloud happens for a variety of reasons. However, securing resources in a multi-cloud environment is a very challenging process. Data that is constantly transient in the cloud and which has to be secured is a highly complicated task. This is yet another challenge when transitioning to a DevSecOps environment. Next one we have is complex tools integration. The majority of DevOps tool chains comes from various vendors like source code management, then we have CI/CD, build tools, binary libraries, code review, and uh, problem monitoring tools. And these are chosen by teams based on their specific requirements. Adding security tools makes things even more complex. So tools like static application security testing, software composition analysis, and some kind of dash tools are typically used in security analysis. However, it can be difficult to combine and reconcile results from different vendors' resources. Next challenge we have is continuous monitoring. Maintaining security in a rapidly changing DevOps environment, it requires continuous monitoring and feedback. So implementing and managing these monitoring solutions can be a challenging one. So we have discussed the challenges, and now let's see the best practices and strategies to tackle those challenges. So we'll see the best practices and strategies in upcoming slides. First one we have is security as code. DevSecOps, which builds on DevOps principles and places additional focus on security activities throughout all phases of the SDLC, which can help organizations realize this ideal state. Writing security policies and configurations as code is an important aspect of DevSecOps. It requires a shift in mindset and the development of new skills. Then ensuring security of infrastructure. Security policies should cover such areas such as access controls, data encryption, network security, and compliance requirements. Next one, we can use infrastructure as code security scanning tools to identify and remediate security issues in your infrastructure code. Then we, in continuous monitoring, utilize automated alerts and notifications to respond quickly to security incidents. And coming to the automation, use automated scripts and playbooks to remediate common security issues automatically. Then for regulatory audit and compliance, regularly conduct security audits to ensure compliance with industry standards and regulations. Then we can use communication and collaboration to address this challenge. Organizations need to prioritize security, investing in training and tools, foster a culture of collaboration, and continuously improve their DevSecOps processes. It's an ongoing journey that requires commitment and adaptation to evolving security threats and technologies. Then tool selection and integration. DevSecOps relies on a variety of tools to automate and integrate security practices throughout the software development lifecycle. So it's important to choose the right tool and ensure they work seamlessly with existing development and operations tools. Then we must focus on automation, as automation is a core principle of DevSecOps. It simplifies the whole process. This is why it is one of the most effective best practices for DevSecOps. Enterprises must automate as much as possible from code writing in an IDE to IAM roles in production to prevent, detect, and fix issues by avoiding misconfigurations. So, here we have another poll to understand the challenges you see while implementing DevSecOps. So, I'm running the second poll. Poll question we have is, what challenges do you see while implementing DevSecOps in your project or organization? Okay, we have options like cultural resistance. Second one is tool selection. Then we have lack of automation or skills and other. Okay, so based on results, I see many have selected lack of automation or skills, and only 33% have selected tool selection. Okay, so let's go ahead and see. So many of us are saying that lack of automation or skills. So the upcoming demonstration will give you more insights. It's time to see the demo of DevSecOps in DevOps pipeline. Here is the project flow of the demo I have created for you. So here I have used GitHub for SCM, source code management. Here I have a sample React based application, and then we have Jenkins for CI/CD tool. So it integrated with different tools listed here. The Sonar Cube is a SAST tool to do continuous inspection of code quality to perform automatic reviews with static analysis of code to detect bugs. Then we have Dependency Check. Dependency Check is an open source tool performing a best effort analysis of third party dependencies. And then we have OWASP. This is a SCA tool, software composition analysis tool. Then we have Trivi. Trivi is a powerful and comprehensive open source vulnerability scanner. So it is basically designed for containers and other artifacts as well as containerized based applications. Then we have Docker running on Azure virtual machine to build Docker images and push the image to the Docker hub. And finally, we deploy the application over the Azure App Service. So for monitoring the Azure virtual machines, which are running Jenkins and Docker, we have used Prometheus and Grafana to monitor the performance and services of Azure virtual machine. In this slide, you can see that the output of the Jenkins pipeline. So here are different stages. The first one is clean workspace. It first cleans the workspace, then it checked it out from Git. So I have used GitHub as my SCM. So it checked out from GitHub repository, and then it does the SonarCube analysis. After that, it waits for the SonarCube analysis to give the output, and it gives the quality gate as okay, or if it gets failed, then it will not continue further. Then it installs the dependencies based on our application. It installs the dependencies. Then it does the scan for vulnerabilities which are there. Then it builds the Docker image and pushes to the Docker hub. And again, we have used Trivi to scan the Docker image if it is vulnerable or not. So here is the another example of DevSecOps pipeline. Here I have replaced Azure DevOps by Jenkins. So in earlier I used Jenkins, now I replaced by Azure DevOps. So my code is residing in GitHub. Then we have used Azure DevOps as CI/CD tool, and SonarCube will do the code quality check. Then we have dependency check to check the dependencies, third-party libraries. Then we have Trivy to scan the code. Again, Docker is used to build the image and pushes to the Docker Hub. And finally, the same application gets deployed over Azure App Service. So this is the output from Azure DevOps pipeline. So here are the different stages. First, it checked out from the GitHub repository. Then it uses Node 16 uh, dependency. Then it does the SonarCube analysis and publishes the quality gate results. Then it installs the third-party dependency, and again it checks the dependency check for third-party dependencies. And after that, it builds the Docker image and pushes to the Docker Hub. Similarly, I have used GitHub Actions to create a CI/CD pipeline. Instead of Jenkins and Azure DevOps, I have used GitHub. This is because many organizations are adopted different tools, CI/CD tools. Like um, organizations are running on Jenkins, some are have their projects hosted over Azure DevOps, and many are using Azure this one GitHub Actions for CI/CD. Then again we have SonarCube for code quality check, and then dependency check. It checks the third party libraries binaries. Then it does the scan using SCA OWASP tool, and on Azure VM, it builds the Docker image and pushes the image to the Docker Hub. And finally, the application gets deployed over the Azure App Service. And this is the output of our GitHub Actions pipeline. So here are the different stages. So we'll see these things in live demo. So coming to the demo one, um, as I mentioned, we have used Azure Virtual Machines. Then our application is deployed by using Azure App Services. So the first one is deployment instance, where I have installed Jenkins, then Docker and SonarCube. Then this instance is used to um, install the monitoring tools like Prometheus and Grafana to monitor the performance and services of Jenkins server. Then these two app services are used to host our applications. Coming to the GitHub repository, so I have used two repositories here. One is DevSecOps project and another is React based application. So these two are based on React only. And if I go ahead and show you the Jenkins, so here if we see the Jenkins pipeline, so first it cleans up the workspace, then it checked it out from GitHub, and then it does the SonarCube analysis over the source code, and then it does the quality gate check. After that, it installs the dependencies, and after that, it does the scan for vulnerabilities. And finally, it builds the Docker image and pushes to the Docker Hub. Then we have Trivy for scanning the Docker Hub image if it has any vulnerabilities in it. So for Jenkins, if I go ahead and show you, I'm using this repository for Jenkins and GitHub Actions. So let me show you GitHub Actions here. Here we have a pipeline created. So let me do some changes here. Let me commit make a change here and commit it over the master branch. Welcome you all to this demo, to this DevSecOps demo, let's say, and let me commit it. Changes made to the test.txt file. Okay, let me directly commit to the main branch. All right. So, very next second, it started building the code here in Jenkins, as well as, let's see here. Yeah. So just now it started building the code and running the pipeline from GitHub Actions as well as from Jenkins. So from out of two repositories, I'm referring this repository, DevSecOps project, for Jenkins as well as for GitHub Actions project. And the second one I'm using for uh, Azure DevOps one. So let me go ahead and make changes in this as well. Let me edit one file here. This is a test file created for demo, and let me do commit. All right. Let me go to the pipeline. And yes, it has started. Let's see these two. Let me go ahead and check this one. Okay, it started building the code. So it has completed sonar cube analysis. First, it checked out from the GitHub repository. Then I'm using JDK 17 to build the code. After that, it has a stage to do the sonar cube analysis. The sonar cube analysis are completed, and we can see the output here. So it has executed successfully. Then we are using node 16 as our sample code is based on React. It has installed npm and built the code. Now running the dependency check. Okay, so yeah, it is doing now dependency check. Till the time, let's see this one. Let me go and open the blue ocean. Okay, so it's it first cleaned up the workspace, then it checked out from Git, then it does the sonar cube analysis. Here we can see the results, and then it just wait for the sonar cube analysis to complete and return the quality gate status as okay. Then after that, it installed the dependencies like npm install, and now it is running OWASP scan. So here we have dependency check to check the dependencies. Okay, till the time, let's see Azure DevOps pipeline. So here also we have different stages like to check out from this repository React CI/CD, and then it uses Node 16. Then it prepares the sonar cube analysis. Then it does the sonar cube analysis and gives us the result. After that, it pushes or publishes the quality gate results, and now it is installing npm dependency. And next stage we have is to check the dependencies. So till the time it gets built over here, let me go ahead and show you the SonarCube integration. So coming to the SonarCube, if you see, we have three projects already listed here. So the first project we have is DevSecOps. So in this DevSecOps SonarCube project, I have the reports which are coming from GitHub Actions. So from this pipeline, once it is done with the SonarCube analysis, it stores the reports or results into this project, DevSecOps. So let me go ahead and see if it has updated or not. We can see just now it has updated and committed the results here. So let me go ahead and see the overall code. It has scanned 3.2k lines, and if I go ahead and show you the issues, so it is listing all the issues which are there in our code, and based on these reports we can go ahead and check the issues, so where exactly the issue is, and why is this an issue. So based on these results or reports, we can take necessary actions and remediate the issues which are there in the source code. Again, the issues are listed here based on the severity, like majority, then critical, then we have minor. So it is coming from GitHub Actions. Then second project we have is gaming app from Azure DevOps. So it is basically coming from Azure DevOps. And if we see, last analysis are done 5 minutes ago. And for this last project, so this one is coming from Jenkins, and it has also published the results in this project. So Jenkins has also done the SonarCube analysis. So all the CI/CD tools like GitHub Actions, then Azure DevOps and Jenkins, they have completed the SonarCube analysis and published the reports in these projects. So let me go ahead and see the Azure DevOps report for SonarCube. Let's see the overall code. Now it is showing that it has scanned 868 lines. And if I go ahead and check the issues, so it has listed one major and one minor issue. Again, we can see where the exactly issue is, and based on these issues, we can take the necessary actions to remediate these issues. Similarly, for this OTT platform, this report is coming from Jenkins. We can go ahead and see this as well. It has scanned 3.2k lines, and if I go ahead and see the issues, it has 13 major issues, 5 minor one, and again based on the issues and the solutions, we can take the actions to get rid of these issues. Okay, let's see the pipelines. Where are they? So now in GitHub Actions, it is running the Trivi vulnerability scanner. After the scan has completed, it uploads the Trivi scan results to GitHub Security tab. So here we have GitHub Security tab. So once it uploads the Trivi scan to the GitHub Security tab, we can go ahead and check those scan reports as well. Okay, let's see the Jenkins pipeline. It is still building. Yeah, still it is doing the FS scan. Let us see Azure DevOps. Now it is building and pushing the Docker image. So it has completed dependency check. This pipeline has no issues. Let me go ahead and walk you through over the Docker Hub registry. So this is my Docker Hub registry, and here I have three different registries to store the different images. So I have named game from Azure DevOps. So this is coming from Azure DevOps. As we see, last pushed was done 3 hours ago. So we are just waiting for the latest one to come here. As we see, Azure DevOps has started building. So once this is done, it will push the image to Docker Hub. So later we'll confirm this one. I think this has completed. Yeah, we can see that it has pushed the image and the image tag is main. So it has pushed just now. Let me see the, yeah. So here in Azure DevOps, it has completed all the stages. And one thing in the artifacts, it has also published the dependency check report. We can download it and look over to check the vulnerabilities which are there, and based on these vulnerabilities we can take the necessary action to remediate and get rid of the vulnerabilities which are there in the code. Okay, so we are done with Azure DevOps pipeline. It has pushed the image here. Let's see this Jenkins pipeline. It is still doing the FS scan. Let me abort the 40-second build, and let's see. Yeah, so from GitHub also it has completed the pipeline without issues. And here in the security tab, as I mentioned, we can see the Trivi report. So this is the Trivi reporting some warnings and critical vulnerabilities. So these are the vulnerabilities which are there in our source code. So based on this report, we can go ahead and take the necessary actions to remediate these vulnerabilities. Okay, just see this one. It is still taking time. And from GitHub also, we can see the image. Yeah, so it has just pushed the image here. We can see this one. 5 minutes ago, it has pushed the image. So this image game, it is coming from GitHub repository, the GitHub Actions pipeline. We can see this here. Yeah. So let's see this one. And for monitoring Azure virtual machines, I have used Prometheus and Grafana. So in this Prometheus targets, I have added Jenkins server, then the local host, this Prometheus machine itself, and then we have node exporter to integrate these targets with Grafana. And we have Grafana to have the dashboards or the UI based dashboard to see the performance and health or services of the Azure virtual machine. So I have already created a dashboard for Jenkins, and if I come here and see the dashboard of the Azure virtual machine, so here I can see the uptime or health, then CPU, RAM utilization, total jobs, and uh, the services. Then, as I mentioned earlier, we are deploying the applications by using Azure App Services. So this is our production application, or we can say to publish our React-based application, we have two different app services used here. So one is production application. Let me go ahead and show you the deployment center. So in the deployment center, it is it is referring to the Docker Hub registry. As I have, this one is my Docker Hub registry, and it is logging in with my credentials. Then it is referring to this image game one. So this is the one, and this has built from GitHub Actions. So let's go ahead and see the results. Yeah. So this is the sample gaming application I have built to show the demo, and we are done with this deployment. The next one we have is to deploy the sample OTT based application. So let me show you deployment center. It has also the same settings as this gaming application. So it is also referring to the Docker Hub registry, and now it is referring to this image OTT. So if I come here and show you that, so this is the one, and this OTT image is coming from Jenkins. So let me go ahead and see. Yeah. So it has completed a Docker build and pushed the image to the Docker Hub. So it is referring to that one, and we can see that a few seconds ago it has published or pushed the image. Let me go ahead and browse this site. Yeah. So this is our OTT based application. Now we have all the three pipelines have built, and we have seen the application results. Okay. In the current dynamic business environment, the significance of robust DevOps practices cannot be overstated. And by investing in top tier DevSecOps methodologies, organizations pave the way for enhanced security, streamlined development operations, and an influential edge within the industry. We can help you for end to end software development by embracing DevSecOps practices. So that's all for today. Thank you all for joining, and we will address all the questions you have submitted via email. If you have any additional inquiries, please feel free to contact us. And using the contact details provided on the screen, and kindly note that a recorded version of this webinar will be made available on our website in approximately a week from now. So we will also send you an email with the link to access the webinar at your registered email ID. So once again, thank you for your time. Have a great day ahead. Thank you. Bye.